Okay, we're starting on a new unit right here. Going to be looking at chemical reactions, and so you guys got done with naming, and I just want to make sure we kind of understand that naming is not something we're going to ignore. That's something we're going to continue to use, and so um, when we're going through these chemical reactions, we are still going to be using those naming items. Okay, so that's going to be something that we're still going to do. Okay, so I think you need to have out a notebook. I think you need to write down your notes. This is not something where I have skeletal notes or a specific handout that goes with these. Normally, I just have students write those in a notebook. So go ahead and pause this, grab a notebook, and write your notes down as we go, just like you would with any PowerPoint, and we'll kind of go from there. So first of all, chemical reactions. We're going to talk about chemical reactions. We're going to talk about a chemical reaction or what a chemical reaction looks like as we kind of go through these. So first definition you're going to have right here. What is a chemical reaction? So here we go. The process by which atoms of one or more substances are rearranged to form different or new substances. So there is the key thing, different or new substances. So when we're looking at a chemical reaction, we're looking for things that are different or new. All right. So what that means is that when you create something new, the atoms are moving around and they're making different items. And we also call this a chemical change. All right. So this is some vocabulary: chemical change, and the chemical reaction. And most of what we're going to be doing today is balancing and writing reactions, but these are some vocabulary bits that we want. So if you make something new, you had some chemistry going on. If you just mix some stuff up and you can separate it out, that's not a chemical reaction. So that's a physical change. But we're looking at the chemical changes today. So, alrighty, take a look there. You've got definitional stuff we want to have here is that we have stuff on the left side of an arrow. We're going to call those things reactants. And then we got stuff on the right side of an arrow. We're going to call these things products. And so we're going to have an arrow in the middle. So you got starting chemicals turning into the ending chemicals. So that's kind of what we got. The reactants are what we start with. The products are what we're going to end with. Now, we're going to use formulas. So when you guys were writing formulas out from names and you're writing that calcium carbonate was CaCO3, well, we want to write out formulas using Ca and C and O and CaCO3. All those things are going to go together to make reactants and products. So everything you guys used in the last unit, we'll just keep doing it. So all right, these are some symbols that could be pretty useful when you're writing out your chemical equations. So the first one is an arrow. So the arrow, it could mean yields. It could mean creates. It can mean combines to form or forms. It can be a whole bunch of words. But basically, when you're reading your sentence about your chemistry that's happening, it'll say, okay, you got these chemicals and we're doing something with them. And then there'll be some word that kind of hints that you're supposed to draw an arrow. So it could be like methane and oxygen combusts to form. So it'd be like, okay, combust or to form would be what I'm looking for. Or it could be like NaCl, sodium chloride, decomposes. And so then you'd be like, oh, decomposes is indicating that something happened. Now I draw the arrow. All right. So you guys have got some practice with that. The other ones are pretty easy. The ones that I've circled in red, S for solid. So sometimes they want us to write down states of matter. Not always, but sometimes. S for solid, L for liquid, G for gas. Those are really easy. And then AQ, that's the weird one. AQ means dissolved in water. And actually most chemicals that we have are dissolved in water. So acids are dissolved in water. They're aqueous. If you have a colored solution I give you in class, then that is most likely something I dissolved in water. So really, most things that you think are liquids are actually aqueous. Most things are not actually liquid unless it's just water or like mercury, which is a liquid, or bromine. But most of the time, everything that you guys think of as a liquid is actually aqueous, something dissolved in water. So think about like if you have like a can of Dr. Pepper, well, it's aqueous because it has things dissolved in it. Sugar being the primary one. Okay, so there you go. There's some things. Do know aqueous that will show up at some point on a test or a quiz. All right, so now we're going to take a look at some examples. And what happens a lot in this unit is you have what we call a word equation, which is a sentence, and then you turn it into a formula. Okay, and so we're going to work through these, and I'm going to shift over, and I've got this Jamboard going so that I can take a look at that. So we're going to slide over here, and so going to zoom in on this one a bit. And we're going to work this one. So once again, how about your periodic table? How about all the tools that you've been using? And so this is stuff that's not totally unfamiliar because last unit we were doing exactly this. We were taking and writing out the formulas for chemicals. So aluminum and bromine, and like this, aluminum bromide. These are things that we were doing in the last unit. So we want to be able to continue to do those things. Right now, I said that the arrow previously on the slide a little bit ago, I said that the arrow would show up and you'd have to find the word that meant arrow. So if you kind of read this carefully, it says aluminum and. So if you see an and, that's going to be a plus. Didn't want that. Wanted my pen here. See and, that's going to be a plus. And then react to produce. So that's kind of like saying, hey, this is where the arrow is at. So we're basically going to have reactants on the left and products on the right. So let's take a look here. Aluminum is a reactant because we start with it. Bromine is a reactant because we start with it. And aluminum bromide is going to be a product. Okay, so we're going to go ahead and write these out. And I'm going to go ahead and write out Al. So aluminum, just Al. And then I'm going to write out bromine, which is Br. And then I'm going to do an arrow. And then I'm going to do aluminum bromide. Okay, now let's think back to our last unit. And remember, we said, okay, you're supposed to look up the charges. So aluminum is +3 and bromine is -1. So we would crisscross those and come up with AlBr3. So this is exactly what you guys were doing in the last unit. Now, gotta talk about Br for a minute. There are chemicals that are so unstable that they cannot be by themselves. And bromine is one of those chemicals. So let's go back to the slideshow real quick, and let's look at this slide right here. And this says skeletal equations and diatomic elements. So we're writing out a skeletal equation right now, and the one we're writing out is there on top. You can see aluminum plus Br. Now notice it says Br2. So Br2, right? Okay, well, Br2, why is it a 2? Well, that's what we call a diatomic. So there are 7 diatomic elements that you need to remember. So you've got hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And you guys want to pause this and you want to write those down. So those elements can never be alone. So if you write down just a Br, it has to be a Br2. If you write down just a Cl, it has to be a Cl2. And they're the diatomic elements. Now there's a way to remember them. You can just highlight them on your periodic table. Or Brinkelhoff is this way to remember them. So Brinchlonf. If you look, the elements spell out the word Brinkelhoff, which is a silly word, but it will help you remember them. So Brinkelhoff. So I'm always asking students, is it in Brinkelhoff? Yes or no? Yes or no? Yes or no? So see, these elements are going to pair up when they're alone. And so that's this idea of diatomic. Okay, so these guys we got to watch out for. The diatomics are going to be a problem when we go through this. So have a tough time switching back and forth. So that may be an issue, but we'll keep going. So let's come back to this one real quick. And so what we said is, okay, now BR, I have to add, oops, don't want to do that. I have to add the 2, right? So I have to add this 2. Now, why am I doing that? So let's go ahead and make a note that this is what we call diatomic. Bromine is diatomic. So let's write down our Brinkelhoff real quick. So we'll go down here and we'll say, okay, Brinkelhoff. So that's kind of the way you want to look at it. So Brinkelhoff. And so then you say to yourself, okay, this is silly. But look, there's bromine, iodine, nitrogen, chlorine, oxygen, hydrogen, and fluorine. So if you kind of follow this pattern, there's bromine, there's iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. There they are. So if you just go through your head and you're like, okay, is it in Brinkelhoff? Yes or no? That will get you the right answer. So if we take a look at this next one, and I had the answer on the other page, but let's take a look at this real quick. Sodium, okay. We're good with sodium. Sodium's Na. Chlorine, Cl. To produce, okay, so there's our arrow again. So arrow, and then Na and Cl. So let's check for charges on the things that are together. So this is together, so we'll check for charges. +1, -1, so they're going to cancel, all right? And let's come back on the left side, and we'll check for our Brinkelhoff. So we come down here and we think, okay, Brinkelhoff. So sodium is not in Brinkelhoff. So we leave sodium alone. This is really important. We only give these little 2s, these 2s, to things in Brinkelhoff. So it's like Br gets a 2. Iodine gets a 2. Nitrogen gets a 2. Chlorine gets a 2. Hydrogen gets a 2. Oxygen a 2. Fluorine a 2. Those all get 2s. Nothing else gets a 2. If anything else is by itself, it's just by itself. So I mistakenly said nickel a minute ago, but look, nickel is just going to be by itself. Nitrogen, on the other hand, is not stable enough to be alone, so it gets a 2. And so we have to spot these and make sure that we give those 2s. So here's chlorine, so we have to add the 2. And those are the diatomic elements, and they can be problems for students because we end up missing them. Okay, now here's the problem that we have to think about. It's only when they're by themselves. So I don't care about chlorine over here. Chlorine is perfectly fine. It's not by itself. I don't care about bromine here because bromine is in a compound, which I look up charges and crisscross. So diatomic is only in situations where the chemical is alone. So this is where we would have to check. If it is not diatomic, it simply is alone. Al, Na, etc. So if you have any element written down in this position that's not a 2, that's going to be wrong. No 3s, no 4s, no 5s, etc. At least for right now. Okay. All right. I'm going to pause this. We'll pick it up on the next video.